Alrighty, let's get into it. Now we're starting to continue our journey through solving systems of equations. This time we'll talk about how to solve systems of equations using elimination. But as I said last time, if you want to solve using a table, a graph, substitution, or some other strategy you use to solve system of equations, feel free to use that. Learning objective today is that you understand how to solve a system by using elimination or substitution and how that creates equivalent systems of equations that would help us solve the original one, right? We're going to talk about how we can add our two systems together to create a new one, what it means to have a solution to an equation and things like that. And so we talked about equivalent equations a few lessons ago, but now we can talk about what it means to have equivalent systems of equations. And so first you are going to take a look at 14.2, right? Take a look at the original system of equations and see what he did. What did he do here? What did that create? And how did he find the solution to an equation? And now you're going to, of course, justify, is that actually a solution to his equation, system of equations? And so make sure you check both of your equations in the system as you are going. This should be a review from last time and in lesson 12. In 15.2, you are looking at a teacher purchasing 20 calculators and 10 measuring tapes for a class and paid $495. It seems like she is a physics teacher, if I'm guessing. Later, she realized that she didn't order enough supplies. She placed another order of eight of the same calculators and one more of the same measuring tape and paid $178.50. And so the system represents the constraints in this situation. And so you can see, like as I always have before, what are the patterns? Where do you see? I see this 20 in the number of calculators. That 10 comes from the number of measuring tape. I also see 8 calculators here. My 8 calculators here, which is my number of calculators, and I have one more of the same measuring tape. Remember, there is a secret one if you do not see a coefficient in front of your variable, right? There's your 1. Now the question is, what does M and C represent? And so as you're going through, ask yourself the question, when you're creating your variables, what am I missing? I have the number of calculators, I have the total cost. So what am I missing? And in this instance, you're missing the cost of the calculators and the cost of the measuring tape, right? C represents the cost of the calculator, or a calculator in this instance, and M represents the cost of the measuring tape. And so if you're ever struggling to create your variables, think about what is missing in this equation. I know how many she bought. I know her total cost. So now what am I missing? I'm missing how much does each cost. And so think about, fill in the blanks, right? The solution to the first equation is all possible combinations. Remember, we can have multiple solutions of the unit prices, right? Of the price of the two items that make a total of, our total amount is $495. Oops, that should be a dollar sign. If I can find the dollar sign, when buying 20 calculators and 10 measuring tape. Now do the same for what the second equation represents, and think about how many possible solutions there are to each equation. How many possible solutions are there to each equation? And you can think about the graph too. Think about what we did in lesson 5. Think about what we did in lesson 12 if you need to go back and see that summary. And so as you continue along, right, what does it mean for the solution to the system of equations, right? Now we're talking about the systems as a whole, as a whole. So both of those equations. Remember, a system of equations represents both of these constraints. Constraints are each of the equations. right? And then you want to find the solution. You can use substitution, you can use graphing, you can use another one of your strategies to find a solution. Furthermore, we are taking a look deeper into our classroom supplies. She then wants to reimburse, because as teachers do, when you purchase classroom supplies, sometimes you have the opportunity to reimburse your items that you purchase. And so now she has her original two equations, right? 20C plus 10M is equal to 495. She has her second equation, 8C plus M is equal to 178.50, right, and 50 cents. And so what does that second part represent? And so what we see here is that if I'm creating my equation, she said she has a total of 28 calculators with the cost of C, and 11 measuring tape, 11M, and that totals to $673.50. Now, where do you see that connection between these two equations? Right, where do you see that 28? Where do you see that 11? And where do you see that 673.50? Right? How is this equation related to the first two? First two are the two I have at the bottom. And of course, then in the situation, what do the solutions of this equation mean? And I want you to think a little bit deeper. How many possible solutions does this equation have? But how many solutions actually make sense in this equation? Think about what you did on the previous slide. How many solutions actually make sense in the situation? What does the equation I have that I will highlight in yellow actually represent? And so think through that, and that's something that we will talk about in class together. Last but not least, you are doing 16.2. 16.2 talks about writing a new system to solve a given system. So then last but not least, we're talking about what it means to do elimination. And so this is a system that we solved by graphing in lesson 12. And to solve the system, Eleanor wrote the two systems together, and see what she did from this step to this step, right? Here was her first step. What did she do here? What did she do here? And think about what it means to have equivalent equations. What did she do to both sides of her equation? Right, she had x plus 2y equals 9, and she had 4x plus 8y is equal to 36. What is your common factor here? And then what did she do next? Right, and she wrote 4x plus y equals 1 and 4x plus 8y equals 36. And this was her result. And the question is, why did she do this? Why did she do this? And this is the start of the process of elimination, which is a method of solving systems of equation by eliminating one variable. And so think about what she did in each of those steps and try to complete that process algebraically. How can you solve for y here? How can you solve for x here? And so as you go through then, in 16.3, we are now taking a look at what it means to solve systems by solve the steps of the system of equations from the original equations given here to find our solution. And so you want to take a look at what it means to go through each of these steps. So here's my original equation. Now, what is my first step here? What is being done to my equation, right? I have my very first step, which is my original equation. As I can see here, this is my original equation. Now, what would a next step look like? What would a next step look like? What can I go from here to my next step? My next step can become, I want to eliminate one of my variables. And so I want to create a common factor between both of them. If I have 4 over 5, if I have 4 over 5x plus 6y equals 15, and I want negative x plus 18y equals 11, I want to cancel out one of my variables, right, using the process of elimination. Using that process of elimination, as you saw on the previous slide, I wanted to, hang on, there we go. well, let me put an arrow there. I want to create a system of equivalent. Remember, all of these are equivalent systems. I'm doing different steps to my system of linear equations to create equivalent systems to solve my equation. I know that my result is going to be a factor of x equals something and y equals something, but what are my steps to get there and what am I doing at each of the steps? Right, so from the first step to the second step, I know that I want to cancel out one of my variables using elimination. See the previous slide. From there, I can find out one of my solutions, which can be found using a process of your system of linear equations, right? First by multiplying one of my factors and then multiplying another one of my factors. And think through each step as you're going through it. What happens at the first step? What happens at the second step? How can I go through this process of step 1 to step 2, right? What did I do here? How did I go from here to here? Right? You can see what you changed. I multiplied by a factor of 5 to both sides because I wanted to get rid of that denominator. Now I have 4x. From step 2 to step 3, I am multiplying the bottom by a factor of 4. And think about why you're doing things at each step. Now I have 2 factors. And if I add these 2 factors together, I know that these two can cancel. 4 minus 4x, and it gives me 30y over 72y equals, right, if I can add these two together, right, my first step, let me write this out, right, let me write this out for you all, and then I will let you do the rest of them together, right, in my first step, multiply 5 to first equation, and I know I can do this because it's equivalent equations. If you do something to one side, you can do it to the other. First equation. Then I multiply by 4 to second equation. Right, I multiplied both sides by 4, and then I add my two equations together. And this is the process of elimination. Once I add those two equations together, I know that this is my solution, my second solution. I know that 30 plus 72 gives me 102. I know that 72 plus 44 gives me 119. I can then solve for y. And once I solve for y, then I can substitute that back into my equation. So think about each step as you're going through. Right here, I added my equations and I solve for y, substituting y back in, y into first equation, and then I simplify, right? This is simplifying. Simplify. Right, so think through each of those steps as you're going through. Double check how each of those create equivalent systems and think about what the equivalent systems mean. And so I know this video was long, but it's definitely important as we move forward to how you can solve systems of linear equations. And of course, the lesson summary goes through another example of how to solve equations using elimination. So I will see you in the next lesson.